Now I am going to explain you about mathematical expectation, another topic. So definition of what is expectation actually. Expected values, we are assuming or predicting the values, is known as expectation. So here we are expecting our numerical values. So how the formula is. So when it is discrete, what is the value, and when it is continuous, what is the value. So here the definition of expectation, mathematical expectation, is given as the expected value of a function phi of x of a random variable x is defined as, so expectation of x, instead of phi of x I can also take e of x, is equal to, we have two types of definitions, discrete random variables and the continuous random variables. So when discrete random variables is there, we are using summation. When continuous random variable is there, we are using integration. So x equal to summation x into p of x, it is a discrete random variable. Integral x into f of x dx is known as continuous random variable. The e of x is called the mean of random variable. So we have addition theorem of mathematical expectation. So if x and y both are random variables, then e of x plus y is equal to e of x plus e of y. So proof of this random variables is given as, if x and y are continuous random variables with marginal probability density functions f of x and f of y respectively, then e of x plus y is equal to double integral, both x and y values are there, no, instead of x we have x plus y. So instead of f of x and f of y, we are considering a marginal density function that is known as f of x comma y dx dy. So both integral, both double integral x plus y f of x comma y dx dy. So we are, so in multiplication form, we are taking two x values separately and y values separately. X into f of x comma y dx dy, y into f of x comma y dx dy. So here one integration I have taken in middle, so that is integral f of x comma y dy and dx, and one is dy and one is dx. So we have a formula like this: integral minus infinity to plus infinity x f of x dx plus integral minus infinity to plus infinity y f of y dy. So here this formula, in this can be written as similarly, this is the same formula of above expectation formula. So e of x into e of y, in the place of x we have e of y, hence the theorem. And similarly we have another theorem, that is mathematical expectation multiplication theorem. So e of x and y both are independent random variables, then e of x y is equal to e of x into e of y. If x and y are two continuous random variables with marginal density functions f of x and f of y respectively, e of x y is equal to double integral x y into f of x dx. So if x and y are both are independent variables, we are assuming, so f of x comma y is equal to f of x into f of y, both double integral x y f of x f of y dx dy. So here integration is multiplied, integral x f of x dx into integral y f of y dy is equal to e of x into e of y, hence the theorem.